For odd number chain length fatty acids, for example, C17, dire-diretso lang yung kanilang beta oxidation process. Just like yung sa saturated fatty acids. Up until they reach 5-carbon na fatty acyl CoA derivative. When they reach this point, a thiolase enzyme will act upon the 5-carbon unit, producing propionyl-CoA and acetyl-CoA. Now, propionyl-CoA is the precursor of succinyl-CoA, which is eventually shuttled in the tricarboxylic acid cycle. Now, propionyl-CoA is carboxylated, so maglalagay tayo dyan ng CO2 to produce methylmalonyl-CoA. Now, this process is biotin dependent. Yun yung cofactor. And then methylmalonyl-CoA is eventually converted into succinyl-CoA in a vitamin B12 dependent manner. Now, yung conversion ng propionyl-CoA into succinyl-CoA is also one of the pathways for the degradation of valine and isoleucine and other compounds. Furthermore, yung conversion ng propionyl-CoA into succinyl-CoA provides also for the precursor of oxaloacetate. Diba remember sa TCA, yung succinyl-CoA natin eventually can be converted into your oxaloacetate, which eventually is converted into glucose. Now, that's how we metabolize yung odd number chain length na fatty acids. Ngayon, paano naman kapag ang gagawin naman ay yung sa very long chain fatty acids? Now, that's a different story because eto, lahat ng napag-usapan natin kanina, it all happens into your mitochondrial matrix. Now, before I forget, also one of the fatty acids that are found in the diet ay yung mga medium chain fatty acid. Now, it's the same thing. Yung mga medium chain fatty acid, they all undergo beta oxidation, and in the process gives us acetyl CoA derivatives. Now, lahat ng to, they all happen into in the mitochondrial matrix. Now, what about your very long chain fatty acids? How are they oxidized? Kung yung kanina, lahat ng nabanggit natin, it happens in the mitochondrial matrix. The oxidation of very long chain fatty acids happen exclusively in the peroxisomes. Now, the reactions that happen in the peroxisomes are pretty much the same with that which happen in the mitochondria, in a sense that it generates acetyl-CoA and NADH. Furthermore, the peroxisomal oxidation stops when the carbon chain length is reached at carbon 4. The carbon chain length is C4 to C6. Some of the long chain fatty acids are also oxidized by this route. Now, in the peroxisomal membrane, we have this long chain fatty acyl synthetase, which activates the long chain fatty acid, and then the fatty acyl derivative enters the peroxisomes in a carnitine independent manner. And now, the first enzyme that is involved is an oxidase enzyme, which catalyzes the following reactions. Now, in the first step of the reaction, your fatty acyl CoA derivative is oxidized, thereby forming a double bond. And then it is coupled by the reduction of FAD into FADH2. However, the electrons that are donated into FADH2 are subsequently donated into molecule of oxygen and it generates hydrogen peroxide. So this step is actually not generating energy. Unlike in the first step of fatty acid oxidation in the mitochondrial matrix, wherein your fatty acyl CoA dehydrogenase is generating energy in the form of FADH2. Dito, hindi. Kasi yung electrons na pinang-reduce mo ng FADH2, idodonate mo lang din ulit into a molecule of oxygen and you generate hydrogen peroxide in the process. And then, kung mapapansin nyo, yung product na natin ay yung merong double bond between your alpha and your beta carbon. Now, eto, dire-diretso na lang din to. It's pretty much the same with the reactions that happen in the mitochondria. So, nandyan yung enoyl hydratase. And then, you also have another enzyme which helps in the production of your ketone, and that is your beta hydroxyacyl dehydrogenase. And then another enzyme which releases the acetyl CoA, and that is your beta ketothiolase. Now, pareho sila ng tawag, itong mga enzymes na to. With that of the mitochondrial matrix, pareho din ng function, but they are coded by a different set of genes. In effect, ito, after your one set of spiral reaction ng beta oxidation, ang end product mo is acetyl-CoA plus fatty acyl derivative na mag-undergo ulit ng another series of beta oxidation plus your NADH. Yung NADH, di ba manggagaling yun dun sa hydroxyacyl dehydrogenase mo. And at the same time, tumitigil tong beta oxidation sa peroxisomes once you reach medium chain fatty acid, medium chain length fatty acid, or short chain length fatty acid. So, as short as butyryl-CoA. Now, let's take a look at the following diagram. So, ito na yung napag-usapan natin kanina, no? Kung saan yung very long chain fatty acids, they are activated into very long chain fatty acyl CoA, and then it is transported into the peroxisomes via a carnitine independent manner, and then it will undergo a series of beta oxidation leading to the production of NADH. Kasi di ba yung FADH2 kanina, nag-transfer ka din papunta ng molecular oxygen leading to the production of hydrogen peroxide. Ngayon, upon the beta oxidation of your very long chain fatty acids, you are producing acetyl-CoA and short chain fatty acyl CoA and medium chain fatty acyl CoA. Now, COT stands for carnitine octanoyl transferase, and then CAT stands for carnitine acetyl transferase. So, anong ginagawa nila? It transfers, or they transfer your fatty acyl moiety, yan, yung mga yan, into the carnitine. Now, itong mga acyl carnitines na to, acyl carnitine, they diffuse into the peroxisomal membrane papunta ng mitochondria. Now, in the mitochondria, they are transported into the matrix, mitochondrial matrix, via your carnitine acyl carnitine translocase. Ito yun, carnitine acyl carnitine translocase. Now, In the matrix, yung inyong short chain fatty acyl carnitine at saka yung medium chain fatty acyl carnitine can be converted back into the CoA derivatives, which are your substrate for another beta oxidation para makabuo ka ng acetyl-CoA. Tapos, we also have your CAT na present doon sa ating matrix, which transfers the acetyl moiety into the coenzyme A, producing acetyl-CoA, and in the process, you are regenerating your carnitine. So, ganun din dito, no? Sa short chain fatty acyl carnitine tsaka medium chain fatty acyl carnitine, nagre-regenerate ka din talaga ng carnitine in the process and your CoA derivatives ng mga fatty acids. Ngayon, once na ma-produce mo na yung acetyl-CoA, ayun na, PCA na. Now, let's talk about long chain branched fatty acids. Now, the most common of the long chain branched fatty acids are your phytanic acid and pristanic acid. Now, they are coming from the chlorophylls, which we consume in green leafy vegetables. Now, it is actually similar to the oxidation of very long chain fatty acids. Now, this process of oxidation actually follows alpha oxidation. So, let's have, for example, the following structure. CH2. Now, this is your alpha carbon and this is your beta carbon. This one, this alpha carbon is oxidized into alcohol and then subsequently into ketone with the release of carbon dioxide. Bale, eto, okay, it will be released as carbon dioxide, and then yung kanina natin na beta carbon, it will become your alpha carbon. Tapos yung fourth carbon mo from the original carboxyl end will now become your beta carbon. So, bakit natin ginagawa yun? Kasi, di ba, normally, wala naman talagang branch dito sa beta carbon dapat. So, the body has to have that mechanism kung paano niya madidispose or magagamit itong branch chain na ito. Bali, once na mawala yung ating carboxyl end as carbon dioxide, yung original na alpha mo will become the carboxyl end, will become now the new carboxyl end. And then, eto, yung beta mo will no longer have a branch, tapos dire-diretso na yan na beta oxidation. Tapos so hindi niya na mai-interfere yung beta oxidation process, and then dire-diretso lang yung beta oxidation natin hanggang makarating tayo ng C8. And then this one is similar din dun sa napag-usapan natin about very long chain fatty acid. Ita-transport mo to papunta ng mitochondrial matrix para ma-process siya into acetyl-CoA. Tapos magagamit mo na siya as source of energy. Another pathway for the metabolism of fatty acids is gamma oxidation. Kanina, yung binanggit natin, that's our beta oxidation, tapos alpha oxidation. Now, in the peroxisomes, meron din tayo nung gamma oxidation. Now, gamma oxidation utilizes molecular oxygen, NADPH, as well as the CYP450 enzymes. Now, yung gamma, by the name itself, no? So, kung meron kang ganitong structure, ito yung gamma end, it is oxidized first into alcohol and then into carboxylic acid. So, in effect, yung final product mo ay dicarboxylic acid. So, you have this and then another carboxylic acid. So, kaya dicarboxylic acid. Ngayon, dalawa yung fate niyan ng dicarboxylic acid na yan. It can be further oxidized, yung beta oxidation, para maging siyang energy, or it can be released in the urine. So, itong process na to, ang importance niya ay yung dun sa ginagawa mong more water soluble yung mga fatty acids na hindi kailangan, or yung mga synbiotics, yung mga drugs na fatty acid in nature na gusto mong i-excrete in the urine. And it is also important to note na yung alpha oxidation and beta oxidation and gamma oxidation, itong dalawang to is not feedback regulated. Yung processes na to ay nakadepende sa amount lang ng substrate or availability of substrate. So that's how we metabolize our fatty acids para gawin silang energy.